Hi, in OpenRAN, we disaggregated some of the functionalities and components. So it is very important that these all components must have good connectivity between them for operations. In this session, we will talk about the front haul connectivity, which is enhanced CPRI or eCPRI, which is the new protocol and enhanced version of 4G CPRI. We will also explore the option of mid-haul connectivity other than the fiber line, like microwave connectivity, which is not a top-notch solution, but yes, we have the option for the mid-haul. We will understand the connectivity between the RUs, radio units and DUs, distribution units, as well as between the DUs and CUs. So first, we will go through with the traditional transport network system, which was used in 3G and 4G networks. The connectivity between the radio access network and the core network is called the backhaul in the traditional network system, which is generally provided by the fiber line connectivity or microwave connectivity. But in the OpenRAN system, baseband unit functions are now separated in the ODU, Open Distribution Unit, and OCU, Open Centralized Unit. Hence, we need the proper communication between these units in order to make them work together. Hence, the concept of mid-haul comes, which provides the connectivity between the centralized unit and the distribution unit. And we also have the front haul, which provides the connectivity between the distribution unit and radio unit. Now the problem is, earlier the front haul has the lower capacity like 1 to 10 Gbps, but as the technology gets advanced, we required more capacity in the front haul as well. At present, it is 10 to 50 Gbps expected. This means the overall capacity needs to be increased from backhaul to mid-haul to front haul. But for the front haul and mid-haul, we also needs to take care of the latency, which is expected to within 0.1 millisecond in the front haul. So the Open Cell Form community came up with the evolved protocol named as eCPRI for the OpenRAN and 5G. However, there is another challenge because ODU and OCU are separated and placed at the different location. So how this level of latency can be achieved if they are placed at the long distance? Here in the screen, you can see old CPRI and the evolved CPRI side by side. CPRI is Common Public Radio Interface. In the old CPRI, which is being used in 4G and which can offer nearly 300 Mbps with 20 MHz bandwidth together with the advanced antenna techniques like MIMO. So that transfer rate is far low from the CPRI capacity, which was designed to offer up to 12 Gbps. However, this also depends on the number of cells connected to the 1 BB unit, but still the number of conversions of frequency to time or time to frequency domain is less from the CPRI capacity. But with the 5G technology, the end-to-end throughput is expected to reach about 20 Gbps, and with more technology enhancement, it may go beyond. And hence, we need to increase the capacity end-to-end. This means front haul also need to be evolved. So instead BBU, in OpenRAN, RU is connected to the ODU and the requirement of front haul is now changed to support up to 100 Gbps. Hence, to fulfill this heavy requirement, a small cell form comes with the new protocol. This is eCPRI protocol, which have the capability to achieve the high number of fast Fourier transforms and inverse fast Fourier transforms through eCPRI. Now let's talk about the mid-haul, which has the connectivity between the centralized unit and distribution unit. The requirement of heavy transfer rate is also applicable here. So the best way is to use the fiber connectivity as a mid-haul. But as an alternative, microwave option is also there from very high frequency range, like ranging from 60 to 90 GHz band like E-band, which can provide the wireless mid-haul between the CU and DU. However, the lower frequency bands which are being used earlier like 18 to 14 GHz or narrow band frequencies like 6 to 15 GHz bands, we cannot provide the new required capacity from those bands. But there is a trade-off in using the higher frequency bands. That higher frequency bands can provide the capacity but cannot serve the long distances. However, the narrow frequency bands can serve the longer distance but they cannot provide the same capacity as E-band. Theoretically, E-bands can offer up to 10 Gbps connectivity in the mid-haul, compared to the narrowband microwaves, which has just 2 Gbps capacity to serve. There is one more downside of the microwave connectivity, and that is availability, which is lower than the fiber connectivity. In the next session, we will be covering that how the 5G networks can be leveraged from the OpenRAN network systems. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.